This Amiga 1000 is completely dead, having suffered catastrophic damage at the hands of the shipping company. In the last episode, we performed some basic tests, repaired the broken case, and thoroughly cleaned the system. Today, let's finish the job and return this groundbreaking machine back to the condition it deserves. I'm Matt D'Amico, and welcome to episode 90 of Retro Bits. So where did we leave off last time? Oh yeah, the broken plastics have been repaired and the case is now squeaky clean. The Amiga still won't boot up, so we need to dig in a bit deeper. Let me cue the music and let's jump right in. Now we've got our first full view of the mainboard, and I'm going to take a look at everything very closely to inspect for any damage before I remove it, flip it over, and then check for any cracked solder joints on the underside. But first, let's have a quick walkthrough of some of the custom ICs on the machine. Starting with the Motorola 68000 CPU, it's a big boy here, clocked at 7.1 megahertz. Next to it, we have the two MOS 8520 CIA chips. Both of these are build dates of the 26th week of 1985, so smack dab in the middle of the year, which kind of confirms our theory that this is a relatively early model of a 1000. Right above that, we have the two bootstrap ROMs. These are just ROMs made by Hitachi. Over here, we have the Paula chip, which has a build date of the 30th week of 1985, followed by Agnes, which has the 25th week of 1985, and then followed by Denise, which is a bit of an outlier with the 17th week of 1988. It looks to me then like maybe Denise has been replaced along with the power supply that we've already looked at. So this machine may have been serviced once or twice in the past for previous failures. Interesting. That's one of the fun things about working on a used machine is you really never know what its history is until you dig into it, and you're always going to find something unexpected. All right, some time has passed and I've gone around the entire board and inspected for any signs of physical damage or trauma as a result of the shipping incident. And unfortunately, I haven't found anything that looks to be like a smoking gun to me. The board is filthy dirty and we'll have to clean it later. But apart from that, it does look like it is intact and I can't find anything that jumps out at me as physically damaged. However, take a look at this. This pin header connects to the writable control store daughter board, and this one appears to have some corrosion on it. So what I've done is I've gone around and I've sprayed all of the receptacles with contact cleaner, and I've also removed each and every one of the other chips and sprayed their sockets with contact cleaner as well, just to rule that out because there is a little bit of corrosion there and that could cause problems. And what I'm going to do with this one is I'm going to take my little fiberglass pencil and I'm just going to scrub it clean and get that corrosion right off of there. I don't know why this one pin alone would have corrosion on it because I only see it on this one, but better safe than sorry. So with that done, I'm going to reinstall the WCS and we're going to retest the machine just to see if that made any difference. And there are a lot of pins that we have to line up just so. So we want to make sure everything is properly aligned and properly seated before we apply any pressure here. So check this out. Before, the LED came on, but it didn't flash, which is the expected behavior during power on. But look now. And look at that, it's now waiting for the Kickstart ROM on disk. So the machine is now displaying video, it's now trying to boot. So I guess what we need to do is get some software so we can try it out and see if it actually works. I can't believe it was that simple and that there was nothing actually really wrong with it. Amazing. Now I mentioned earlier that the Amiga did not come with its original keyboard. And while I could use a PC keyboard with an adapter, the Amiga keyboard has a pretty unique layout, so I'd like to use something like this, which is my Amiga 3000 keyboard. In order to do that, I'm going to use this little adapter that converts the Amiga 3000's DIN connector to the Amiga 1000's RJ11 connector. In addition, we're going to need a mouse, and so my plan is to use this tank mouse that came in the Toronto estate sale auction lot. The only real difference is that the Amiga 1000's mouse has a 90-degree connector, but otherwise they're pretty much the same. You'll notice that there's a discolored stripe on this mouse where a rubber band had been used when it was in storage. So I am going to get these things disassembled, I'm going to get them cleaned up, and then I want to try out the new vapor method of retrobrighting. And through the magic of YouTube, all the parts are ready for their spa day. I've never tried Vaporbrighting before, but the new process is said to be fast and effective. Further, it doesn't require the parts to be submerged in liquid or covered in caustic goop, so I'm keen to try it. Here's the setup. This new method requires food-grade hydrogen peroxide at a concentration of 10% or higher. Unlike with the older submersion method, you shouldn't use stabilized hair care products like this. I'm not really sure how much to use here, so I'll err on the side of caution and start small. I can always add more later. With Vaporbrighting, there's less risk of streaking or blotching, and it supposedly can work indoors even without direct sunlight. One drawback is unstable peroxide will degrade more quickly, so any extra you might have left will have a shorter shelf life. You'll also need a container that's relatively airtight. This storage box has a rubber gasket built into the top and latches securely. Within a short time out in the sun, the entire container has clouded up and we can see bubbles that have formed in the liquid. I'll monitor this throughout the afternoon in case I need to add more peroxide or if it looks like it's done. I don't want to whiten things too much. We'll see how the Vaporbrighting process worked in a bit, so while we wait for science to happen, let's see about getting the system to boot and run some software. My eBay Amiga didn't come with any media, so I'll need both a Kickstart ROM disk as well as a Workbench disk. For that, I'll use my trusty copy of Amiga Forever, which has a neat utility called ROM Toolbox. It lets you export Kickstart images in a variety of formats, including a bootable disk image for the A1000. It also includes an assortment of Workbench disks, so I'll grab one of those as well. Eventually, I'll create real boot floppies from these images, but for testing purposes, I plan to use a Gotek drive running the Flash floppy firmware. It's just more convenient and flexible when it comes to testing. All I need to do is copy the disk images to a USB stick and number them accordingly. I'll also need to check the configuration file to make sure it's set up for the Amiga. Most of the defaults are fine, I just need to ensure it's set up to use a ShoeGuard interface. I can specify that explicitly, or configure the setting with jumpers on the drive, which is what I've opted to do. And here is the Gotek drive I plan on using. It's running the Flash floppy firmware, and according to the manual, and I'm sorry it's going to be very difficult to read the silk screen there, I need to make sure that S0 is jumpered, where I previously had S1 jumpered for the K-Pro I was using this on. I also need to make sure that JC is open in order to force the drive to operate in ShoeGuard mode, which is what's required for the Amiga. Now, in order to connect the Gotek up to the Amiga, I'm just going to reuse the existing power and data cables from the built-in floppy, making sure that I connect the data cable pin 1 to pin 1 on the Gotek. And since the Gotek is already configured as device 0, it will become the new boot floppy. All right, let's flip the switch and see what happens. Did you hear that? Yeah, the A1000 plays a little jingle after it passes its self-test. That must be built into the Bootstrap ROM, and I don't know any other Amiga system that has that little jingle on PowerUp. And did you notice it's now asking us for a Kickstart disk, not a Workbench disk, because we still need to load Kickstart into the writable control store. So to do that, we'll select disk 0 on the Gotek. And there we go, now it's loading Kickstart into the WCS. This only has to happen one time. Once it's in there, you can reboot the machine as many times as you want and you don't have to repeat this process. And now with Kickstart loaded into the WCS, it's asking us for our workbench disk. Great, so all this is working. Now I just need to select drive 1 on the Gotek. And there we go, booting up into Workbench 1.3, good old blue and white. I'll be honest, I was a little disappointed on how easy it was to get this machine up and running. I thought we'd really have to dive deep into the troubleshooting, but the good news is that does leave us more time to test out the machine and work on those damaged plastics. And there we are, the Workbench screen is up and running. We have a functional Amiga with 373 KB of free memory, and not very much.
Retrobit saved my life. Don't forget to like and subscribe.
A quick diagnostic shows that all of the RAM is functioning properly. In fact, all of the tests are passing just fine. It seems like we might have a very healthy machine here. Not what I was expecting at all, but I'll take it. Since the mainboard repair took less time than expected, that gives me more runway to fix everything else that's wrong with this Amiga. Starting with the missing expansion port cover, I was able to find several different 3D models online, so I picked one that looked nice and ran off a copy using my printer's high quality setting. Here's the filament that I bought, and it's supposed to be color matched to the Amiga 500. I'll put a link in the description, you can check it out for yourself, but let's see how it does color matching an almost 40-year-old Amiga 1000. Are you ready? Oh wow. Wow, that is really close. That's amazing. Given that this thing is as old as it is and a little bit yellowed, the fact that this matches up at all, that's shocking. That's really good. I'm quite pleased at that. That's $20 well spent right there. Very cool. Next, I want to print an eject button to replace the missing part on my machine. This Amiga 1000 has a floppy drive made by NEC in it, model FD1035. While I found several eject button models online, none of them were for this make and model, so it may be a less common part. I did find a replacement for a different model NEC drive, so I started from there and modified it to work with mine. Once I verify that it fits, I'll post my remix to Thingiverse in case someone else with this specific drive needs it in the future. Alright, here's my 3D printed eject button, also made with the Amiga filament. Naturally, there were a few iterations along the way, but that's to be expected when you're dealing with this sort of stuff. Let's see how it fits here. Goes on just like that. And then we just take the cover, the front faceplate, slips on just like that. That's a pretty nice match as well. Quite pleased with that. The bed of my 3D printer has a slight texture to it, so in order to match the finish of the A1000's case, I'll also wet sand the eject button and expansion cover a little just to smooth them out. In terms of mounting the cover, there are supposed to be clips on each side that lock the piece into place, and I say supposed to be because when you're printing extremely small parts in PLA on an inexpensive printer, of course, they're fragile, and of course, they both broke off. So what I'm going to do instead is this. If we look inside the expansion slot, there are two metal posts with screw holes for securing accessories, and they are large enough that we can take a kitchen magnet and... So what I've done is I've taken two of those magnets, cut them down, filed the edges to make them square, and then epoxied them onto the cover. And there we go, just like that. With the replacement parts taken care of, I want to do something about the broken power switch. If you recall, the Amiga is always on no matter what position the switch is in. I unscrewed the switch from the power supply, and fortunately the specifications were embossed on the side, which gives me a place to start looking. Have you ever tried finding an identical replacement part for a 40-year-old device? After taking measurements of all the dimensions and pouring through the thousands of different switches in the parts catalog, I was shocked to discover that one manufacturer still makes what appears to be a similar product. An encoding scheme is used to identify each model they produce. Mechanism, poles, rating, mounting, and of course the dimensions are all packed into the part number. I narrowed my selection down to two available parts that should fit the bill. The first had a white rocker with straight terminals. Close, but not the beige we're looking for. The second candidate had a black rocker and solder lug terminals. I've heard that some Amiga 1000s came with black switches, so I went with the second option. And here is the original switch that I've just desoldered from the power supply. And this is the replacement part that I've just ordered. Let me see if I got the right thing or not. All right, at first glance, they look the same. Looks like I've got the dimensions correct. Yeah, I think this is gonna work. So the only question is, do I want to swap the beige rocker from the original switch onto the new switch? I mean, the black would look good, but I think I want to retain the original aesthetic of the machine, so I'm gonna try and swap the rocker over. Now, the rocker switch is held in place by these two metal tabs that are sort of just crimped into place. In order to extract the plastic part, I'm going to have to pry up on these two tabs, but I don't want to put too much pressure against the plastic because I don't want to damage it. So there's not really many places to get purchase on them, so I'm just going to have to be gentle. There we go. All right. And now to repeat the process on the new switch, but it looks like these metal tabs are a lot flimsier and made of thinner material than the original switch, so it should be easier to get it out. Yeah, they are a lot thinner. Yeah, that was so easy. Okay, awesome. And now, just to put the old part into the new switch. Just like that, there we go. New switch, original rocker. All right, the new switch is installed, it's all soldered into place, and it's a perfect fit. Cool. With the physical repairs well in hand, let's check and see how the Vaporbrighting is going. The keyboard wasn't nearly as yellow as the mouse, so I took it out after just one afternoon. With a second day in the sun, the mouse was starting to look better, but a third day didn't seem to yield any further improvement. A line is still visible where the rubber band was wrapped around the mouse in storage, and it's not coming out. A quick rinse is needed to remove any residual hydrogen peroxide. Be sure to use caution when handling and disposing of the leftover material. At these concentrations, it's caustic and will burn your eyes and skin. I also want to even out the front of the case. The part I wet sanded is now less yellow than the rest, so I thought I'd try a little sun brighting. This process takes much longer than retrobrighting with peroxide, and unfortunately the weather didn't fully cooperate, with rain being forecast for the rest of the week. I did get 3 good days of sun, and I'll keep working on the Amiga after the video is done. For now, this will have to do. Overall, I'm impressed with the new Vaporbrighting method. It requires less peroxide, works quickly, and has less risk of streaking or blotching. I think this will be my new preferred method going forward. Before I call this job complete, I'll apply some UV protectant spray. The hope is this will slow down any re-yellowing that might happen in the future. I've had good luck with numerous projects staying white even years after being retrobrighted, so I feel like this is cheap insurance, even if I have no empirical data to back it up. Right, so here's a reminder of what we started with. And how did this battered and broken Amiga 1000 turn out? I've gotta say, I'm really pleased with how this piece of history cleaned up. Wet sanding did alter the texture of the repaired area slightly, but the end result is still far better than I could have hoped for. There are still a lot of broken tabs on the faceplate that need to be repaired, but I'm not sure what the best method for that is yet. Let me know in the comments if you have any ideas. I've still got some work left to do, but I think we can call this project a resounding success. Is it perfect? Nah, it'll never be perfect. But it works great and it's got character. More importantly, I now have a deeper connection with the machine, something you just don't get by purchasing a like-new example to sit on a shelf and look pretty. I guess what I'm trying to say is, don't be afraid to go out and find your own bruised and broken classic and give it a second chance on life. I hope you enjoyed this bit. Thank you so much for watching, and we'll see you next time on Retro Bits.